All right, class, welcome. Today, we're going to dive into one of the most powerful tools in a financial analyst's toolkit, integration. Now, I know what some of you might be thinking. That word can bring back some, let's say, not so fond memories of a pure math class. But I want you to know, in the world of business, integration isn't just some abstract thing from a textbook. It is the fundamental way we make precise, smart decisions when our numbers, like costs and revenues, are always changing. It's how we go from a rough guess to absolute financial certainty. So let's get into it.
So think about a situation you're absolutely going to run into in the real world. Let's say you're a manager at a factory making some new, high-tech gadget. That very first one you make, it's going to be super expensive. Your team's just learning, things are inefficient, the whole process is slow. But then as they build the second, the 10th, the 100th one, they hit their stride. They get faster, more efficient. We call that the learning curve, and it means each new gadget costs less to make than the one before it. Or, hey, what about the opposite? Maybe you're making furniture. Demand is through the roof, so you start buying up way more lumber. But that huge demand might actually drive up the price of wood, meaning every new table is actually more expensive to build. In either case, how do you figure out the exact total cost for a run of 1,000 units? You can't just multiply by an average price. It won't be accurate enough for a real budget. This is the exact problem we're here to solve.
You know, in managerial accounting, we really deal with two basic kinds of cost. On one side, you've got your fixed cost. That's the easy stuff. If every single widget costs exactly $10, 100 of them will cost $1,000. Price times quantity. Simple, right? But that's rarely how the real world works. Most of the time, we're dealing with what you see on the right, variable costs, and specifically a situation where the cost to make the very next item, we call that the marginal cost, is always in flux. And that's where this big question mark comes in. It represents a huge challenge. How do we get a total when the cost isn't a flat, constant number?
To figure this out, we first need to actually see the problem. I've always found that in business math, if you can understand the shape of a financial question, you're already halfway to the answer. So we're going to start with something you all know really well, a basic rectangle, and then see how it transforms into the challenge of a curve, which, believe it or not, is exactly why calculus was invented in the first place.
Let's go back to our simple fixed price example, but this time, let's look at it as a graph. See this? The total cost is just the area of this rectangle. The width of the rectangle, that's our quantity, 100 units. The height is the constant price, $10 a pop. So the area, width times height, gives us our total cost of $1,000. This visual idea, this area equals total, is absolutely fundamental. So I want you to burn this image in your mind because everything we do next is going to build on.
But here comes the reality check. That nice, flat, predictable $10 line, it almost never exists in the real world. What we actually have is a marginal cost curve. As we make more stuff, the cost of the next unit changes, and that creates a curve instead of a straight line. Maybe it slopes down because we're getting more efficient, or maybe it slopes up because materials are getting pricier. And just like that, poof, our simple, easy-to-calculate rectangle is gone. We're left with this new curvy shape, and we can't find its area, its total cost, with the simple geometry we all learned in high school.
So how do we handle this? Well, the first step is just to think logically. If we can't calculate the area of this weird shape all at once, what if we break it down into shapes we do know how to measure? Imagine we just slice up that whole area under the curve into tons of super thin little rectangles. We definitely know how to find the area of each one of those. And if we add all those little areas together, we can get a really, really close approximation of the total area, or, in our case, the total cost. It's not a perfect answer just yet, but it's a massive step in the right direction.
This powerful idea, this concept of summing up a whole bunch of tiny rectangular slices to get a perfect, exact total, well, that's the whole idea behind integration. This is the tool we need to go from a pretty good guess to the perfect answer.
Because, let's be honest, in finance, close enough just doesn't fly. You can't walk into the CFO's office and say the production run will cost approximately $4.5 million. They need the real number for budgets, for pricing, for everything. So, what if we could take our slicing idea to the absolute extreme? What if our rectangles were infinitely thin and we could add up an infinite number of them? Well, that's exactly what calculus, and specifically integration, lets us do. This precise operation has a name. It's called the definite integral. And its entire job, its whole purpose in life, is to find that accumulated value under a curve between 2 points, like from making unit 0 all the way up to unit 100. It's the ultimate tool for adding things up, giving us the exact area and so the exact total cost we're looking for.
And this isn't just some abstract theory we're talking about in class. As our source material states very clearly, this has a direct, critical application in the business world. The area under that marginal cost curve is the total cost. It's that simple. By calculating that area, we are calculating a real-world financial figure that drives major decisions. All right, enough theory. Let's put this into practice. I want you to imagine you're a new financial analyst at a manufacturing company. The chief financial officer, your CFO, walks right up to your desk. She's got a challenge for you. The company's thinking about a new production run, and before she signs off on the budget, she needs to know the exact cost. That's your job.
So here's the info the CFO gives you. The engineering team has figured out that the marginal cost, that's C prime of x, the cost to make the x item, is given by this function, 50 minus 0.1x. Okay, let's break that down. This tells us the very first item, when x is basically 0, costs about $50 to make. But for every single additional unit you produce, the cost of that specific new unit drops by 10 cents. It's a perfect model for that learning curve effect. So the question she leaves you with is this: what is the total variable cost to produce the first 100 units?
So we solve this with a clear, methodical process. There's a playbook for this. First, we identify our marginal cost function. Check, she gave it to us. Second, we define our production range, what we call the bounds of integration. In this case, that's from unit 0 to unit 100. Third, we set up the definite integral, we write out the problem in the language of math, and finally, step 4, we calculate it to find that exact total cost.
And this is what that looks like. This one little expression right here contains our entire business problem. So let's decode it. That big, stretchy S is the integral sign. It just means sum everything up. The 0 at the bottom and the 100 at the top are our bounds. We're summing from the start, unit 0, up to unit 100. Inside the parentheses, that's our marginal cost rule. And the dx at the end, that just tells us we're adding up the costs for every tiny change in x, for every single unit. So, when you actually solve that integral, and this is where you'd go through the mechanical steps of finding the antiderivative and plugging in the numbers, you get this, $4,500. And I want to be crystal clear, that is not an estimate, it's not an approximation. It is the precise, exact total variable cost to make those 100 units, perfectly accounting for the fact that every single item got a little bit cheaper to make. It's a beautiful example of how this tool gives us true financial certainty. Now, knowing how to punch the numbers into a calculator is one thing. That's a technician's job. But understanding what the answer means, and just as important, knowing the common traps to avoid, that's what turns you from a student into a real financial analyst. So, let's nail down the most critical point of confusion I see all the time. You have got to understand the difference between marginal cost and total cost. Marginal cost, C prime of x, is a rate. It's a snapshot. It tells you the cost of just one item, the very next one coming off the line. Total cost, the integral, is an accumulation. It's the sum of the costs of all the items over a range. You can never, ever confuse a rate of change with a total accumulation. One is a derivative, the other is an integral. They are opposites, and they mean completely different things in business. So why am I hammering this point so hard? Because getting this right directly translates into the skills that will build your career. You simply cannot create an accurate budget if you don't know your true total costs. You can't set a smart price for your product without this information. This math is the absolute foundation for figuring out if you're actually profitable, and it informs every major decision a company makes about production and finance.
And please, don't think this is just a tool for analyzing costs. It's way more versatile. As our source material points out, you can apply the exact same logic to the other side of the equation. If you calculate the area under a product's demand curve, you get the total revenue. It is the exact same mathematical tool, just looking at the money coming in instead of the money going out. It's incredibly flexible.
So I'll leave you with this final thought to really chew on. We've just walked through how to find the exact total cost. Now, what happens if you apply that same precise method to calculate your exact total revenue? What does that unlock for you as a future business leader? Well, it means you can build a model to find the exact point where profit, the gap between revenue and cost, is at its absolute maximum. You can determine the perfect price to charge and the optimal number of units to produce. You stop guessing and you start knowing. And that, right there, is the entire reason we apply mathematics to the world of business.